Rồi để mình trên câu.
Mr. Lawrence.
Do people hear me?
Dạ cái mail mà mình.
Yeah.
Yes, we can hear.
Okay. Good morning, good afternoon, everybody. Thank you for joining this webinar on water and agri-food, an integrated approach to the Mekong Delta. My name is Laurent Noemans. I'm the climate change and water management expert at the embassy in Hanoi, the embassy of the Netherlands. And I will moderate this webinar. This webinar is part of the digital trade mission of the Netherlands and several Southeast Asian countries. And we focus part of the webinar series on the Mekong Delta. And this one will focus on the linkage between agriculture and water. And you see the content table. We will start with an introduction of Karel Richter and then a scene setter. Thereafter, we have block 1 on flood-based systems, where we will look at the agro-water interactions. Then we will go on with block 2, where we have retention solutions to keep the water for agriculture in the dry season. And then block 3 on the salinity challenges more along the coast, where we have very different water conditions. Thereafter, we have a Q&A and a short moment where companies that attend the webinar can express their interest to meet other companies. And this is part of the trade mission. I will have some closing remarks. First of all, I would like to introduce Mr. Karel, the different speakers. Mr. Karel Richter, he will be the first one to provide some opening remarks. Without further ado, I would like to give you the floor, Karel.
The Mekong Delta is the heart of Vietnam when it comes to agricultural production and food production. In the future, it is predicted that the demand for all these products from the Mekong Delta will increase. That is because of national growth, but also because of free trade agreements, such as the one between Vietnam and Europe. That will boost export. With growth and an increased demand for all these products from the Delta, it is important to focus on sustainability, efficiency, and resilience. The only way to address those challenges is to look at them from an integrated approach. It's a combination of water management and food production and looking at the supply chain. In order to address all these challenges, we have to bring all stakeholders together: government, knowledge institutes, and private sector. Together they have to produce innovation and creative solutions. I hope today this platform will give you the opportunity to share knowledge and find each other in order to contribute to this objective.
Thank you, Karel, for your opening remarks. This is indeed the purpose, not only to link agriculture and water, but also to link business, knowledge, institutions, and policymakers, and the general public. Now, I would like to introduce Gerardo van Halsema, who will set the scene for the rest of this webinar. Gerardo, the floor is yours.
Thank you, Laura. I'm just trying to find my presentation. What is it? Not working. You see my presentation, hopefully. So I'm going to present, give a very quick overview of the complex situation on how we can use agricultural development in the future to adapt to the very changing circumstances that are caused by the impacts of climate change, and how we can foster synergies between the changing hydrology in the Delta and future agricultural development. As we all know, the impact of climate change is causing a lot of changes on the water resources in the Delta, with higher peak floods in future, but also very low floods, as we've seen last year, delay flow, increase of salinity, increased droughts, and increasing water shortages in the dry season. These have already today huge impacts on the environment and the degraded state of the environment, but also impacts on the economy, which is still based on very low value, mainly rice-based agriculture, whereas there are opportunities to increase those agricultural and economic developments in the future. There are a nascent but still unexplored tourism, which provides new potential in the future, and is governed by, at the moment, still very weak vertical and horizontal linkages in the agri-value food chains. Looking at the impacts on the water resources base, we can come up with the new agricultural development zoning for the future, basically distinguishing different zones, as we see here in the upper Delta, which will be permanently fresh water, can be secured throughout the year, and is very suitable for rice and freshwater aquaculture. Along the coast, we will have large areas of saline environment governed by salinity intrusion, which are very suitable for aquaculture. An area in the middle of the Delta, which is very high valuable for the cultivation of high value fruits and vegetables with permanent fresh water, and are basically the most difficult zone that we are dealing with, which is a large intermittent zone between the permanent fresh and the coastal saline zone, which is intermittently fresh during the monsoon period, but will become increasingly saline during the dry seasons due to saline saltwater intrusion, which is suitable for rice shrimp cultivation, but also we're looking at new developments for salt tolerant fruits and vegetables. At the same time, these new environments, or these changing environments, also provide opportunities for regenerating the forest, both in the saltwater areas as in the freshwater areas. I'll briefly go through these zones. We're looking at the upper fresh floodplains. We're looking at restoring and retaining the floodwaters, so restore the natural function of the floodplains, keep as much water, fresh water in there, which will be very suitable for fresh water rice cultivation, of course, but also fresh aquaculture, freshwater aquaculture, and higher value products like floating vegetables, which Andrew will shortly tell us more about. The principles that we're looking at is to restore the flows of sedimentation, of wild fish stock, and improve the soil and water quality in this area. It also provides then the opportunities to use this area to restore the wetland forest like the Melaleuca and link those with lotus development as a natural environment linked, giving opportunities for tourism. So the focus is on how can we provide high value livelihoods based on agricultural activities that are flood-based. This area, however, is also facing quite some challenges. And when we look at the new reduced target the government has set for the future to produce 17 million tons of rice per year, and we all want to put these in this upper flood zone area, it is quite small. So the pressure will continue to keep triple rice also in this area going. What we've seen last year, the very low floods is also a challenge as they undermined most of the flood-based agricultural systems. So measures will have to be taken to counter these. And worries in the future exist. How can we cope with extreme flood events that are likely to occur? On the other side, when we look at the coastal saline area, we've seen over the last years a huge increase of the salinity in intrusion, and we need to embrace these in the future. So embrace salinity as a productive asset. We can use it to produce very high value aquaculture products. And the basic principle that we're looking at in here is to restore the circulation of water and the exchange of water with the tidal influence, making shifts from monoculture in aquaculture to polyculture, abstain completely from the use of groundwater as this leads to land subsidence, and connect our aquaculture systems, reconnect them with mangrove regenerations along the coast to improve nutrient cycle, coastal defense, and nature restoration. Potentials for high value agriculture are quite high. The principles are to shift from monoculture to polyculture. We can use natural systems where we combine carnivore fish with herbivore fish as treatments for potential disease carriers in the water before we use the water for shrimp systems, and design new aquaculture systems which are based on separating water intake from channels with water discharge channels, so that the waste management is much more better managed, and connect these systems with the mangroves as natural nutrient cycling systems. In the middle of the delta, we're basically dealing with three zones: the permanent fresh zone, which is our valuable zone with good alluvial soils, very suitable for high value fruits and vegetables. And in particular vegetables, there's still a lot of potential to develop new products in there. The challenges there is that it will increasingly come under pressure of salinization. And our challenge is, can we provide enough fresh water supply during the dry season from the upper delta to these valuable zones? And can we secure a sustainable water management principle which is based on the circulation of water and avoid blockage of water, which leads to the accumulation of pollutants? The most challenging zone by far is what we would call the intermittent zone, which is fresh during the monsoon due to heavy rainfall, but will be increasingly more saline and for a more prolonged time saline during the dry season. So we need to shift in our agricultural systems from fresh in the monsoon to saline or salt tolerant in the dry season. The natural system that copes, that is well designed for this area is the rice shrimp system. And we will see that this will increase over the next years as a very suitable system, which can also provide a good livelihood. Groundwater in this area is not an option as an additional source of water for agriculture, as it will lead to land subsidence. The challenges that we have, we see increasingly shifts to fruits and vegetables that are salt tolerant or very short season, like pineapple, coconut, and agave. But there will be increased demand for new types of crops, both fruits and vegetables that are salt tolerant. So I'm looking very forward to the presentation of the salt doctor, and hopefully he can bring us with some new scope of cropping strategies in this area. Also in this area, again, it's very important to ensure the water circulation throughout the year to avoid water pollution issues. And on the other hand, we have areas which have been lowering due to land subsidence and are losing their natural drainage capacity. So these are creating stagnant ponds in the landscape, which, especially during the rainy season, will lead to waterlogging and water pollution hazards. And these are areas in the landscape that are suitable to regenerate nature with flood forests that can retain the water during the wet season and can be linked to fish and agriculture systems during the dry season. The key principles basically that we're looking at in the adaptation is to restore the free flow and circulation of water, sediment and fish in the delta and restore its self-cleaning capacity. Enhance the fresh water retention wherever we can, stop the use of groundwater as a source for agricultural development, and see our salt water as a very productive asset for high-value agri and aquaculture. There are also increasing opportunities to restore the nature and link those to ecology-based agricultural systems that are suitable also for the increasing demand for tourism on the delta. So the adaptation options and the zoning arise basically from combining the changes that we see happening due to climate change in hydrology with the suitability of soils and the options we see for the restoration of nature. These are challenges, but also very nice opportunities. Thank you.
Thank you very much, Gerardo. And Gerardo, please have a look at the Q&A at the bottom of your screen. You see already 4 questions coming in, and I hope you can answer these questions of the participants. I would also like to point out that Vietnamese participants can listen in their own language when they press the interpretation icon at the bottom of the screen. Thank you, Gerardo, for this nice overview and the different zonings zones in the Delta. And that is actually also the basis for the flow of our webinar today. And we start in the Upper Delta with the area that is flooded in the wet season. And then we gradually move to the next block where we will have more about the Middle Delta, and finally in the third block we will come to the coastal zone that you described. So now I'd like to move to the first block, which is on the flood-based systems. And I would like to ask Andrew to give a presentation of their work and the practices that are the agro-water practices that IUCN is promoting. Andrew, the floor is yours.
Thank you very much, Laura.
เคยคุยกับเขาโดยตรงไม่เคยค่ะแต่เขาคุยกับหนูเมื่อวาน
Sorry, I don't see. Okay, thanks, Laurent. Okay, our lessons, I'll put our lessons up front here. We've been working for the last 3-4 years on flood-based livelihoods in the 3 Upper Delta provinces of Anjang, Dong Thap, and Long An province. They indeed offer a feasible and scalable water retention solution for the Upper Delta, with some caveats. In comparison to other ideas of water retention, the flood-based livelihoods flood storage is seasonal, so keep this in mind, in tune with the natural flood pulse. The flood release, for example, is timed with cropping calendars because they're actually an application of water retention in agricultural landscapes. A major challenge with them, and again for this audience, you may be interested to know that they face a problem with their value chains in that they're quite underdeveloped, only with very little investment in their value chains. So there's opportunity here, of course, in these challenges. One is that they're quite suitable to produce organic products from, and there are export markets to be exploited, which currently the level of exploitation of export markets is quite limited. Some of these, what do these flood-based livelihoods look like? Well, I've got some pictures, images here in 2 different contexts. The first context on the left-hand side of the graphic is to applications to conserve existing flood areas, so conserving the water retention area of the Delta. On the right-hand side are solutions to restore the water retention area, in other words, to reclaim the flood area inside the rice polders or the high dikes. Just focusing on the conservation of water retention areas, so in the low dike areas. These are existing models. They're actually all local models that currently exist already. Rice aquaculture systems are one of the systems that are currently being supported by the World Bank project, for example. The lotus farming systems are systems, diversified systems that we ourselves, ASEAN, have been working on for quite some time. There are floating rice upland crop systems, which GIZ assisted with their development, as well as Anjang University, and the Melaleuca plantations, which are quite popular in Long An province. You'll note that the solutions for restoring water retention areas are quite limited, and this is where the real challenge exists. We are able to do intensive lotus inside the high dikes because they can actually grow through the dry season without surface water being present. There are examples of floating crops like water caltrops that are possible inside the high dikes, grown within the very short 3-month flood season within high dikes. And out of all these models, the only introduced model that we have are the floating vegetable gardens from Bangladesh. We've introduced them in order to find more solutions to apply inside the high dikes. Let me just talk about the incentive for farmers here. This is a very good publication questioning triple rice intensification on the Vietnamese Mekong Delta floodplain that was published in 2018. So if you're looking for evidence about the profitability of these flood-based systems, this is the paper to go to. I don't have time to go into this, but what I've shown there is the comparison between flood-based crops in blue with the mono rice crops, the 2 rice crops and the triple rice crops. And if you compare those figures on the right-hand side, you'll see that the profitability of these systems are greater than the mono rice cropping systems or 2 rice crops or triple rice crops. Let me just show you the possibilities of these types of crops, in particular lotus, which is probably the most developed in terms of its value chain, but needs still needs further development. So Lotus products actually can supply products to food markets, traditional medicine markets, ecotourism and flower markets, and the fiber markets. Amongst this, the food markets are probably the most developed, as well as the traditional medicine markets. There are existing ecotourism areas in the Mekong Delta, and the flower markets are fairly well serviced. But the fiber markets is something very recent, and these images of some high-value fabrics that are now being produced from lotus yarn. This is well established in Myanmar, but only recently introduced into Vietnam. Let me move on to the floating vegetable gardens, which we introduced from Bangladesh in 2018. These are some images here from the very first pilots we did with the Anjiang Fruit and Vegetable Company. And some of the lessons that we had from this is that it requires much more research and development investment to make it feasible, partly because the higher Vietnamese labor costs compared to Bangladesh make these livelihoods unprofitable. And so there's innovation required in less labor-intensive construction methods. They're ideal for high dike applications because they're protected from the waves caused by river traffic, so they're not really feasible outside of the high dikes. And they're suitable for the short duration flooding of 3 months or less inside of the high dikes. There are business models that need to be tested for large-scale application. For example, using labor cooperatives that produce these platforms at the end of the rice harvest season. They could be sold to farmers for profit, and they can provide vegetables in times of high demand, low supply. These are some images from the pilots that we did. The platforms are made from water hyacinth, and we have abundant sources of water hyacinth that clog up our transportation systems. One platform can clear around about 20 square meters of this water hyacinth from the clogged up canals. Some further images. And these are the types of vegetables that are possible that we've tested on these platforms. The soybean there is a product that Anjiang Fruit and Vegetable Company actually exports. So they were quite interested to see whether we could grow soybean on these platforms. This is a successful pilot that we did in Dong Thap. The reason being that it was piloted in a low dike area, so exposed to river traffic and waves, which break up these platforms prematurely. Let me finish with this last slide. From IUCN's perspective, these flood-based livelihoods offer a nature-based solution that can be applied in agricultural landscapes like a floodplain ecosystem to conserve and restore the floods. They'll reduce infrastructure costs, for example, avoided costs for high dikes. We can conserve and restore the floodplain and their ecosystem functions, whilst farmers can make profits from the floods simultaneously. We reduce soil compaction through increasing sediment deposition. And finally, we can conserve aquatic habitats and increase biodiversity in fisheries. I'll finish up there. Thank you, Lauren.
Thank you, Andrew, for this explanation. And to underline the point of the water retention, we will now watch a short video.
Here behind me we see the Cambodian floodplain and also the Vietnamese border. The floodplain is now underwater and the farmers are cultivating fish. After that they will grow rice. But in Vietnam, at this side of the border, the farmers have built high dikes to protect the land against the water, and they can grow 3 crops of rice. Of course, this is giving them much more returns. But this solution also comes with its own problems. For instance, the water that was used to be stored here now is causing some inundations elsewhere, and it also causes more drought because the water is not stored upstream. It cannot balance the water deficit during the dry season. Furthermore, there's a lot of pollution and soil degradation in this area. So it is needed to make another transformation. It's not going back to the floodplains of Cambodia, but it's making a step forward to flood-based agriculture that is productive and prosperous. So we invite all of you to contribute to this process of transforming the agriculture and water management in the Mekong Delta. Thank you very much.
Thank you very much, Willem Schoustra, my colleague, agricultural counselor in the Embassy of the Netherlands in Hanoi. So we see that floods have been traditionally considered as a threat, but there are also many beneficial aspects to the floods. And the flood water that is retained during a flood is a valuable resource for agricultural production. We will show in the second block of this webinar a number of retention solutions, because it's not only in the upper delta that water needs to be stored for the dry season, it's throughout the delta. And the first example that we will see is from the FAME project introduced by Geoff. Geoff, the floor is yours.
Thank you, Laurent. As Laurent had mentioned, my name is Jeff Zimmel, and I am a hydrogeologist at Deltaris. I'm just going to try and... I'm here today to present on FAME, freshwater availability in the Mekong Delta. And although this slide deck is on a Deltaris template, we do have a number of project partners. The Division of Water Resources and Planning in Southern Vietnam, as well as the Center for Water Management and Climate Change, also in Vietnam, Royal Haskoning, Vác Ninh University, Nilan Schumans, and then our funding agency, RBO. So as Gerardo already mentioned, drought, subsidence, and saltwater intrusion are just a couple of cherry-picked ideas that accumulate to a triple threat environmental disaster for the Mekong Delta. You don't have to look very far in order to pull headlines, whether it's from scientific literature or from the media, in order to see the impact that's currently going on, both on a environmental and from a social perspective. So FAME itself is focusing on water availability at a farm scale. And instead of focusing on the surface, we look at, from a subsurface perspective, looking at the geologic and hydrogeologic perspective, and whether or not the subsurface is suitable for storing water, fresh water, to be then used at a later date. In order to do this, as I mentioned, we're looking at the suitability of the subsurface, and we're monitoring surface water as well as groundwater quality, but the levels as well. So we can try and figure out if we are able to store water underground. The purpose of FAME is to construct and install a small pilot system in order to develop a working model or a blueprint for aquifer storage and recovery systems within the Vietnamese setting, as well as map the upscale potential for use at other locations within the Delta. So what is aquifer storage and recovery? As I alluded to on the previous slide, it is a way to store fresh water in the subsurface, keep it safe until when it's needed. It's very similar to managed aquifer recharge, and sometimes the terms are used interchangeably. So if you do see that on your search, just keep in mind that they are very similar in what they do and what they are made for. So the concept of aquifer storage and recovery can be applied to supplement water quality as well as water quantity. It can be infiltrated in deeper or shallower systems, and it could be infiltrated or injected under pressure or allowed to infiltrate naturally through creeks, ponds, or something of that nature. As you can see on the right, they can be simple or complex. They can be set in urban or rural environments, and they can be adapted to shallower, deep geologic and hydrogeologic conditions. The water can be filtered, put back to nature, or stored for future use in the subsurface. A couple of programs Deltaris has run and is currently running in the past are CoStar and GoFresh. So if you are interested in more information on aquifer storage and recovery projects, I would point you to those two topics or programs. So FAME itself is an ongoing project, and where three potential pilot sites were selected within the Mekong Delta, one potential site in the province of Tra Vinh and two potential sites in the province of Ben Tre. So looking at the subsurface, we took a number of shallow hand borings up to 4 meters deep and a handful of deeper wells in order to find the aquitard for the surface sand, or the phreatic aquifer, the upper aquifer. So we're looking at shallow systems within the FAME setting. We are collecting a little bit of rain gauge data as well as electroconductivity measurements, which is a proxy indicator for saltwater intrusion. As mentioned, all of this information helps us build a hydrogeologic conceptualization for the area to help better assess the suitability for aquifer storage and recovery systems. Not only do we look at the water quality and water quantity, but the social impacts and discussions with farmers on crop types, length of the season for each cropping variety, and water use at the locations is interesting to us as well. We strengthened our water quality monitoring program within 2020 and pushed back the aquifer storage and recovery pilot install to early 2021 so that we can better understand the water quality within the area. If we look briefly at the Ben Tre 3 field site, saltwater intrusion was mentioned, and this is relatively close to the coastal zone. But what we see here is surface water points that were collected November through mid-December of 2019. The orange points are were collected at the start of November, whereas the red points, which is a 5 times increase in electrical conductivity, were taken mid-December. So this just shows the increase in salinity in the canal system close to the potential pilot location as we move from the wet season into the dry season. So if we look at that last Ben Tre 3 site longitudinally and look at it in a third dimension in depth with a cross section here, we can see that as we move from the wet season into the dry season, we see a decrease in groundwater level within the upper aquifer system. And this is because farmers are using this water for agriculture and livestock and sometimes domestic purposes. So the concept of FAME is to take fresh canal water when it is fresh, before the salt water comes, before saltwater intrusion takes place, purify it if necessary, and store it underground, raising the groundwater level so that we reduce the amount of groundwater level drop that we see into the dry season. So we're hoping to augment the water quantity or water availability for farmers and trying to make a dry year a normal year within the Mekong Delta. Water quality is an issue and it shouldn't be taken lightly. So phosphate and nitrate contaminations is fluctuating. So at different times of the year from the groundwater and the surface water, we see that sometimes the phosphate and nitrate levels are above the regulatory limits and sometimes they're below the regulatory limits. So within the FAME project, we're also hoping to bring light to water quality issues within the pilot sites. So what's next? We're hoping to continue to work with project partners and locals to install and develop a blueprint for aquifer storage and recovery, as well as upscaling this idea. We'd like to continue monitoring water quality and quantity. We are continually building relationships with organizations interested in developing aquifer storage and recovery concepts further. This can be farmer associations, communities, water managers, other companies. and better understanding the deeper geologic systems and the suitability for aquifer storage and recovery applicability. This could also help with the subsidence issue if you balance the amount of water that is taken out with the amount of water that is injected, so you don't reduce the pore pressure in the subsurface system itself. Very grateful to be here today, so thank you for your time, and I'll hand it back to Laurent.
Okay, thank you, Geoff. It's very nice to see how you establish the link between water and water storage and agriculture, in the sense that you enable farmers in the future to maybe grow one more crop. I would like to encourage Gerardo and Andrew to look at the Q&A and to start answering the questions that were posed to you there. That would make the webinar more interactive. In the meantime, we will move to a short movie. It is about the water quality that Geoff just mentioned as being crucial. It is not a good practice to infiltrate dirty water in the sand layers in the delta. That won't help much. So the water quality issue is important and will be shown in the next short video. Thank you. This was an insightful video of Fresh Studio. And to further highlight the importance of water retention and the quality of water, I would like to give the floor to Romano from VEI, Vitens Evidence International, who will focus on the drinking water issues. Romano, please tell us about your activities in the Delta.
Yes, we are doing some water resource. Is my presentation also there? Because I don't see it. But I can tell you something about the activities that we have in the Delta. First of all, I agree with my background is a water engineer that worked at Evides, one of the drinking water companies in the Netherlands that is working, cooperating with peer-to-peer with local water companies. We are working with Kanto Wasako, Kanto 2 Wasako, Hawasuko, and Soktrang to exchange our knowledge about water production, water safety plans, and how we can maintain these. My presentation, I would like to mention that the water source and the water quality is very important. As we've seen in the other videos as before, the salt intrusion is is getting into the land, so that the water quality is a little bit bad also for drinking water, but also for agriculture. We have seen these issues also in the Netherlands because we are having similar problems in the Dutch Delta, and where we have this solution to have these reservoirs, which my company Evides also have, to store the water when the water is flooding, so that you have an extra capacity, and also that you also have a pre-treatment step for your water before you get it in the treatment plant. So that's we hope that we can work with agriculture and the drinking water together to have multi-purpose reservoirs where we can store the fresh water in the times that the water is fresh and not included by salt. We are doing this for Evides since the years of 90s, 70s, and we also upgraded the reservoirs that we have. And this is, we also having dams for preventing the salt intrusion. So it's very important that we can work together as water companies, but also agriculture, to work together in these times where salinity is a big problem. Also in the Mekong Delta, we are having, because of the use of many groundwater sources, there's land subsidence. And this can only speed up the salt intrusion as the sea level is rising and the land is subsiding. So that's where we have to be very careful about using the groundwater instead of surface water. I would like to stop my my presentation here. Sorry that I couldn't share it.
Okay, thank you very much, Romano. We will now leave the block of the water retention behind and proceed to block 3 of this webinar, the salinity challenges that Romano also mentioned already. This also is definitely an aspect of the water quality we have been discussing. The first item in this block is a short video from the salt doctors. Please show us the video.
The Salt Doctors is a social enterprise from the Netherlands, and our mission is to improve crop yield under saline conditions. Also in the Netherlands, this is important because salinity is also a big issue here. There are a lot of ways to prevent salinity problems in the Netherlands, but also adaptation is becoming more and more important. So we worked in the Netherlands for 10 years on the search for salt-tolerant crops. And we have found crops like potato, carrot, cauliflower, many other vegetables that are much more salt tolerant than the conventional varieties that are being used right now. So these varieties can help farmers to become more resilient and adapt to climate change and adapt to salinity. So we introduced a salt-tolerant potato variety in Pakistan, and there the yield increased by 40% just by using this salt-tolerant potato variety, and also focus on soil and water management. Also in Bangladesh, we trained 5,000 farmers how to adapt to salinity, how to use these crops, and there the income of these farmers increased by 34% 2 years after the project started. Salinity worldwide is a very big problem. Up to 1 billion hectares is salt affected, and also half of all water resources are salt affected. But we know now we can use these resources for food production, and in that way saline agriculture can really contribute to food security in many countries worldwide. We help with teaching and training, but we also help with setting up pilots and demonstrations in the field, and we always have a very practical approach. So we are an implementation partner, helping different farmers, different organizations to adapt to salinity.
It's very encouraging to see that the Q&A sessions are now lively and dynamic. To continue with the salinity challenges, I would like to introduce again my colleague Willem Schoustra from the embassy in Hanoi, who is doing an interview with 2 experts. Willem, the floor is yours.
Thank you for giving me the floor and the opportunity to interview 2 very knowledgeable people. My name is Willem Schoustra. I'm the agricultural counselor to Vietnam and Thailand. I have the honor to moderate and interview this session about salination, saline problems, saline challenges, but maybe also saline opportunities. The Mekong Delta is under threat of climate change, as we already heard, and saline circumstances are becoming more and more a problem for the current agricultural system. So that also might imply that we want to change that system. And we have 2 experts here, Arjen Vos from the Salt Doctors and Jan Verhagen from the Wageningen University. Very much welcome, both of you. And both experienced here in Vietnam. We're doing research and taking forward initiatives to make use of this saline circumstances and to see how we can use it in favor of production and in favor of food security. So Jan, let me start with you. You are a scientist working for the Wageningen University, experienced in the Mekong Delta and also experienced in saline crop production. Based on your experience, what to your opinion should be taken into account when we think of production of crops in saline conditions?
Yeah, thank you. One small correction. I work at Wageningen University Research. That's just the thing that we are proud of, that we combine the 2. So that's a small addition. With regard to saline conditions and agriculture, it's basic. It's not that different from other agricultural activities, because agriculture is still largely an economic activity. So markets are critically important, and the context in which you do agriculture. So also the social economic setting. Specifically for saline conditions, because this poses obviously a serious issue for crop growth and also for animal husbandry. In many cases, we see a few things. You have to have the right material to start off with, you have to have the right knowledge, and you have to have the right context in terms of markets and logistics to work on this. So in that sense, it's not, as a system, it's not that different. It's only the saline conditions that you need to focus on to get production going in these areas. Having said that, markets are internationally also competitive, so this is also something to take into account. The Netherlands is also struggling with this issue, obviously, and it's also then moved into an opportunity because saline conditions in deltas are not new, and it's something that will increase over time. So it also provides a sort of a forefront of science how to deal with these stress situations. And this links very well to the drought conditions in large parts of the globe, because salt and drought, they're often combined. Part of it is physiologically the same for crops. So that is the context is the critical one, and technologies are a way to work on this, I think. Thank you.
Okay, Jan, thank you also sharing for this based on the experience you have with this topic. Maybe Arjan, if I may say, Arjan, you have lots of experience with improving crop yields under saline conditions, and also recently worked in the Mekong Delta. What is your approach to make it successful in the Mekong Delta?
Thank you, Willem. So we did around 10 years of R&D in the Netherlands, where we really focused on identifying salt-tolerant varieties of conventional crops. And for us, it starts with that we look at the adaptation. We consider the salinity to be there. You know, you really have to adapt to the salinity, and that's especially true for the dry season in the Mekong Delta as well. So if you have varieties of conventional crops that are more tolerant to the saline conditions, then it's much easier to still get good yields under these saline conditions. And of course, it also takes the training of the farmers and the extension officers. And it also takes a lot of demonstration in the field, because, you know, it's, yes, saline agriculture is quite comparable to normal agriculture, but there are also quite some issues that are new. So you really have to showcase these solutions in the field. So we always have a very practical approach. We really focus on the implementation, and we started up with a first training in the Mekong Delta, but also with a first pilot in the field to really showcase the possibilities, because what we saw was quite moderate salinity levels in the Mekong Delta in the dry season. And then we know there are a lot of options for different crops to cultivate them under these saline conditions. And that's what we're trying to do.
Thank you, Arjan. That sounds promising. That also means there is hope for the Mekong Delta to adapt to these saline circumstances and to embrace the salinity, let's say. Jan, maybe I can go back to you. Listening to this approach of the salt doctors, what could Wageningen University and research add or offer when it comes to research and education?
Yeah, thank you for the question, and thanks, Arjan, for making that clear, because that's also spot on for the work we're doing. We're an agricultural university, basically an engineering university and research, if you like. So we do combine with real world issues. So we do want to work in the field as well. That's why a lot of the research we do also links to lab experiments, but also to farm field experiments, as Arjan is doing. And making that connection is critically important, because there you also see things that breeders can do and that farmers can do. There are different responsibilities within that knowledge chain, if you like. So farmers can do a lot, and they're already doing a lot, and we can learn from that as well. So that is something we're trying to do. What Arjan is also doing is making use of the existing gene pool, trying to find ways of using that gene pool in the field with farmers. And that's exactly what we need to map, because if we can find out the right crops and the right genes, we can actually try to breed that into other crops. So that is something what we're also working on. That's research, but also linking then to the farmer. Then we also move into the educational bit. And Wageningen, not per se Wageningen itself, but the Dutch green education system is very much linked to the farmer. So it's even vocational training that we were doing in a lot of countries. Taking part of the technology, the knowledge and the skills to the field, and taking the knowledge from the field back to the research. And that is something that seems to be very helpful in trying to understand the situation that farmers are using, and also in adoption of certain treats, and even water management, small-scale water management, water purification. You can think about a lot of things that we can do. So that is the way how Wageningen works. So we need to be in the field, and this year has been obviously a dramatic year for doing that, but that's I think we will catch up next year.
Thank you, Jan. We all hope that we can catch up next year, and also thank you explaining that it requires to bring different stakeholders and different expertise together, not in the last the farmers itself, but also it needs vocational training, education, and research. And I think that is also what makes the Netherlands strong, that we really can provide this integrated way of thinking and also working in practice. So thank you for sharing that. Arjen, back to you. You have witnessed the challenges in the Mekong Delta with your own eyes. What would be your dream when you have unlimited resources for the Mekong Delta? What would be your inspiration? Please share it with us.
Well, it would be really nice, of course, to have unlimited resources. Well, there's still a lot of work to be done. You know, what we've seen in the Mekong Delta, it's quite comparable to the problems that we also see in the Delta of Myanmar, in the Delta of Bangladesh. So the salinity is really linked to the dry season. But the thing is, during the rainy season, there's plenty of water. So it's also a matter of holding on to the water in the rainy season, so you can make use of it in the dry season. You know, that will prevent a lot of problems already. That's why we're always teaming up with water organizations. So in the Mekong Delta, we work together with IHE Delft, because the water harvesting during the rainy season, storing it and making use of it in the dry season, for sure is part of the solution. But the solution is also quite complex, and some issues take several years to develop, because every location has its specific problems. And as Jan also mentioned, it also has to fit the socioeconomic conditions, of course. Well, that takes time to really develop scalable solutions. For that, it would be ideal if you can have several years of implementation, several years to build up a network of different stakeholders, but also include several farmers where you can really put it into practice. There's also still part of research that needs to be done. So it would be ideal if you can have a center in the Mekong Delta where you can do this research to develop the scalable solutions. So that's focusing, of course, on the right crops, but also your soil management and your water management. Drip irrigation, for instance, is going to be important. And you can also combine it with the cultivation of fruits. So you can think more of an agroforestry solution, and that can also help with some natural drainage, stuff like that. Well, all these aspects take time to develop. Time to showcase. So it would be ideal if you have a central location where you can really put everything together, including organizing all the input materials, so it will also be locally available. And I think that's our ideal situation, that we can really put together one central location where you can include all the different stakeholders, where you can combine the education and the training and the research, but also focus on the scalable solutions, make sure it's cost effective, and then introduce that solution to a network of farmers who really implement it. And then you can really showcase it on a larger scale, include more and more farmers. And in that way, you go from scalable solutions to actual, the impact. You know, that's what we're aiming at, of course. If you look globally, how much land is salt affected, how many millions of farmers are affected by salinity. Well, it all comes down to scale and impact, of course. And yeah, we believe that the Mekong Delta can be a central location where you can really develop and showcase the solutions that are available. So ideally, we focus on that. Set up a center, work with the stakeholders, showcase the solutions, and really put it into practice for long term.
Thank you, Arjen. Thank you for sharing your dream. It's a big dream. It's a long-term dream, but it also shows, hearing to your explanation, that it is feasible. So that is also very good to hear. So if we really bring the right resources and the right partners together, and today you, together with Jan, showed what you can offer to overcome the challenges in the Mekong Delta with your expertise, your network, and your organization. So thank you so much for sharing.
Okay, thank you, Willem, Jan, and Arjen for this lively conversation on salinity. It is interesting to see that all of you see the opportunity that salinity, which is usually seen as an enemy, not necessarily is an enemy. If we know how to adapt to it, it can be a valuable resource. And this will also be further explained by an example of Marco van Duivenvoorde. He is telling us more about sea-based agriculture. Marco,
yes,
the floor is yours.
Yeah, thank you, Laurent. Welcome, everybody. I will share the screen right now. Oh. You all see my screen already? Because I have some...
Yeah, it looks good.
Yeah, okay. Yeah, so again, welcome. I will tell you a bit more about what we are doing. We are a seaweed farm. We are a group of the Netherlands, and we are farming and we are cultivating and processing seaweed in Europe and as well as in Vietnam. We are cultivating seaweed in the Nha Trang area and Cam Ranh. And next to that, we have a company called Sea Flavors, which is trading seaweed and developing products out of seaweed. And our third company is a marine byproducts company. We valorize shrimp and fish waste. Yeah, so what we are doing in Vietnam, we started in 2018 with a local Vietnamese partner. We are cultivating a seaweed species called Caulerpa. And we are cultivating on land. So yeah, what we are doing is getting the water out of the sea and put it in the big ponds. And yeah, that works quite well. The application for these products is for food and aqua feed. So a lot of our products go to shrimp farms. And next to that, we are preparing the cultivation of Kappa ficus and Aspergillus. Those are two species which are quite popular. The Kappa ficus for the binding industry and the Aspergillus as a methane reduction for cattle. And what we are doing right now is we are facilitating local aqua farmers with infrastructure, so lines, and we explain them how to cultivate seaweed. And next to that, we are planning a processing plant where we will processing seaweed and make the seaweed suitable for their applications like feed and food. So yeah, the opportunities we see in Vietnam is that there's a growing international and regional market for seaweed. And yeah, there's a big demand from the feed companies in Vietnam, but also for feed, but also mainly from China. Why we choose for Vietnam? Well, first of all, we were asked by a Vietnamese entrepreneur to see if there are opportunities in the Nha Trang area for cultivating seaweed. And next to that, the climate for cultivating seaweed is very nice in Vietnam. We are one of the companies who really like salinity. So at the moment it's very bad because of all the rain is falling. So a lot of our seaweed died because of the lack of salinity. So there's also another story about salinity. We also experience that the people are highly motivated. So they really want to learn and they want to see what other options the ocean has for them. And another reason choosing for Vietnam is the combination with seaweed farming and the existing fish farms. All the fish farms and shrimp farms, they have a lot of fish faces, and those fish faces are actually a problem. But for seaweed, they are some kind of a blessing because it's a fertilizer, and the seaweed grows very well on it. So we use the seaweed to clean the water actually of the fish and the shrimp farms. Yeah, the challenges we saw was like starting a business, but we solved it by having a local experienced seaweed farmer as a partner. And as I said, my business partner in Vietnam is a Dutch Vietnamese. Another challenge is that there is not a lot of knowledge yet about seaweed cultivation in Vietnam, but we are working on that. We work together with local universities. And another problem, and especially this year, is the rain season. As I said, there's a lot of rain falling, and the ponds we have on land where we cultivate some seaweed in, yeah, there's a lack of salinity, so all the seaweed died, unfortunately. The solution for that is that we are looking for cultivating seaweed, more offshore, so that we can lower the seaweed when salinity is low, and yeah, then we can also play a bit when temperatures are too high, and that it can damage the seaweed. So how can how can the Mekong Delta benefit from seaweed cultivation? I always call it coastal reforestation. Well, if you start cultivating seaweed on a large scale, it will benefit the local biodiversity. The seaweed turns the carbon dioxide in a biomass. It's also a water cleaning system, because the waste of the fish farms, it can be used as a fertilizer for seaweed. We did some testing in Norway, and we saw that between 20 and 40% of the fish faces were absorbed by the seaweed. So it can definitely clean the water. And also the nitrification. Seaweed uses a lot of or uses nitrogen, and a lot of agricultural fertilizers has nitrogen in it, and it will come with the groundwater in the sea. So actually seaweed can clean this up. It also has some safety opportunities. Sea levels are rising, and seaweed actually turns salt water into fresh water. So the minimum content of fresh water is at least 50%. But there are also species which have more freshwater content, and at the moment we are testing a drying facility where we catch the evaporated fresh water and then use it as fresh water for, well, maybe put it on the land or use it as fresh water for drinking. And it also can work as a storm barrier. So there's a lot of flooding in the Mekong Delta, and we see that in other countries where they try to build seaweed farms, and these seaweed farms, they absorb the energy of the incoming waves. So that can also be a extra opportunity for starting cultivating seaweed. But for us, we are now in the Cameron area, and we're definitely looking now at the opportunities in the Mekong Delta, and they are definitely there. So hopefully next year we will have our first farm in the Mekong Delta area, and so that we can give our own share and help the Mekong Delta and give it a very good future. So I hope it was all clear, and if there are questions, contact me. And thank you again for giving me some time and a platform. Thank you.
Thank you, Marco, for bringing also in this business perspective. In the previous interview, we saw the academics. This is very insightful, your experiences and also your openness to talk about it. Now we are moving to the Q&A session of this webinar. There are already some questions in the Q&A and in the chat, but I also got a question that is related to the groundwater extraction and the land subsidence that was mentioned by Romano and by others. And for this question, I would like to invite Alexander de Ruiter from the Arcades to present the project he's working on. Alex, could you tell us about how Arcades is working on the interface of groundwater and subsidence, working together with the local authorities and many stakeholders?
Yes, thank you, Laurent, for the question. So Arcades is working together with IUCN and the Center of Water Management and Climate Change on the Dutch-funded project about the governance of land subsidence and groundwater management in the Delta. We've seen in the studies that hydraulic heads in the aquifers have been dropping quite a lot in the past 30 years, and land subsidence has been going up and reaches 4 or 5 centimeters in certain locations. And the recent studies have shown that it's linked. So we've spent the past year working with 4 provinces in the Delta: Benche, Sokchang, Kanto, and Kianjiang. And we've been looking in and assessing how their current policy is tackling these issues. So we've created fact sheets that outline these problems specifically for each province and their governance challenges. And currently we're moving forward into collaborating with them on the execution of the Decree 167. So this decree instructs the different provinces in the Delta to create zoning plans. And these zoning plans according to groundwater restriction. The restriction and then the amount of restriction is based on different criteria, including groundwater, including land subsidence. And for us, we see our most important contribution to this into regional coordination of this, because currently the provinces are doing this separately. And obviously the aquifers, they're all, well, they're regional. They don't restrict themselves to provincial borders. And we've also noticed that neighbors are having issues that on one side of a border, there is a lot of extraction still possible, while it's completely restricted on the other. So we hope that the consortium moving forward together with the provinces will be able to prevent some of these issues and reduce groundwater extraction, but also contribute to having a more regional approach to this.
Okay, thank you very much, Alex. I see in the chat box another interesting question from Steven Starmans of Mekong Delta. It's a question for Marco. These fish and shrimp farms use a lot of biocides, and they're also in the effluents. Will this not be a risk when you use this for seaweed?
Yep. It will be a risk, or well, maybe not a risk, but it's we do a lot of food and feed grade applications, and those clients they always ask for a report, and there we test things like the biocides, but also heavy metal things. So that can be a risk, yes, definitely. But there are so many applications, so there are also applications where it's not a risk. So if you more go to bioplastics or things like that, but until now the levels of all those biocides are not a problem. So they're in between levels. But yeah, and also we prevent to start cultivating in areas where those things are an issue. So we really look at the area where if there is any a lot of groundwater which is poisoned or something like that. So yeah, we look at it, and it is a problem. Okay. Yeah.
Yeah, no, it's also interesting. It might link up to an idea of Gerardo van Halsema on the polycyclical aquaculture, whereby the effluents of fish and shrimp farms are, for instance, cleaned in mangrove patches that are on farm. I don't know, Gerardo, whether you want to respond to this question, and is your polyculture system also considering seaweed?
No, I think I was very happy with this introduction of a new cultivation, which was to me unknown, but I think it fits very well in the same kind of thinking. So where we try to come up with restoring water cycles, and also the cycling of nutrients from different systems. And I think so the combination of this polyculture with mangrove and with weeds, seaweeds, I think looks very promising. So I expect to be able to make good connections there.
Yeah.
Maybe we can. Yes, Marco.
Yeah, they're already in our area. There's a company called Australis, the big barramundi farm, and they're already experimenting with seaweed and those barramundi farms. So just to clean up the fish faces, but also in Europe, in Norway, a lot of salmon farms, if they want a new license, they are obliged to cultivate seaweed around it just to clean up a bit of those feces. And you can also combine it with sea cucumber. So all the feces which drop to the bottom can be eaten by the sea cucumber. So we are looking for a combination of seaweed, fish, scallops and sea cucumber, and I think that's really an interesting combination.
Yeah, and then there is this question from Kan Ho. who affects maybe all of the discussions at the moment, how the increase of water temperature affects this fish, shrimp, and seaweed shellfish systems, because we take climate change as a starting point for the transformation of the Mekong Delta. And of course, that has to do with rising temperature, not only rising sea level. So who can explain what is the effect of temperature increases on these aquatic systems?
Especially what we see in the monoculture pond systems, the shrimp and these aquaculture become very sensitive to very high rises in temperature. I think part of it is by restoring water circulation in the system. So get away from the stagnant ponding. We already solve a lot of that problem because you keep adding fresh water of a lower temperature, not giving it the chance to rise in a stagnant pond. And I think if the source of the water gets too high, then adaptations need to be made in stocking levels. And again, I think shifting from monoculture to polyculture provides you better opportunity to work in higher temperature settings.
Okay, thank you, Gerardo, for this. I would like to close this Q&A session and then move on to the next session, which is the business-to-business moment. We have a few minutes in this webinar whereby I would like to invite exclusively the entrepreneurs, the companies, to raise your hands by using the button at the bottom of your screen, to raise your hands in order to express what is the kind of business partner you are looking for. And this webinar is part of a trade mission which wants to link businesses to knowledge institutions, but also to businesses. And that last step is quite difficult. So I only would like to invite people from the private sector to express what kind of partner are you looking for, whether it's a Vietnamese partner or whether it's a Dutch partner. Let's see who wants to respond. Is there any of the participants who is looking for a business partner in this area of agriculture and water?
I am.
Yes, please go ahead.
Especially for the salt doctors, with anyone who is working in the coastal areas. A year ago, we have had an idea to create a salt campus in one of the coastal area provinces. And it seems to me that this is the good moment to try it again. So with I and the FOS and probably even that we can work together to create a salt campus where we build the knowledge and we have a place for experimentation and showcasing for saline agriculture.
Okay, thank you very much. Who else wants to raise the hand? And the moderators can give the floor. Okay, if nobody else, then I come to the closing remarks of this webinar. We took you along a journey from the upper delta to the lower delta. And from the topics like water retention and flood-based agriculture to saline aquaculture. These are examples of how water and agriculture are linked together and need to be treated together in an integrated perspective. It is important to not only link water and agriculture, but it's also important, we saw, to link the commercial enterprises with the knowledge institutions and the policymakers and also to get the broad support of farmers for the transformations that are needed in order to adapt to climate change and to make the Mekong Delta more resilient. We had an interesting journey. I would also like to invite you for a next webinar that we are organizing as an embassy, which is on Wednesday the 9th. It starts at 3 p.m. Vietnamese time and 9 a.m. the Dutch time. And that webinar will focus on water technology. And we will show Dutch solutions in the areas of water treatment, smart water, water storage, the recovery of nutrients and energy. And I hope that we will meet you again in that webinar. It's Wednesday the 9th at 3 p.m. Vietnamese time. Thank you very much for your attention in this webinar.